This is checking your understanding for whether or not you understand like what parallel and perpendicular slopes mean. A quick review I'll do over here in the corner. If you have a slope that equals something like 2 over 3, or we'll say 2 over 5, okay? The perpendicular slope would be that flipped, so I got to flip it. I got to put the 5 on top and the 2 on the bottom, and then the sign changes. So this one's positive, this one's negative. Those are perpendicular. The parallel slope is going to be the same. So parallel slopes are the same. Perpendicular slopes are flipped and the opposite. So now let's look at the slopes that are given to us in number 14. Right here for this one, it gives us -4 and positive 1 over 4. Is that parallel, perpendicular, or neither?
I say it's neither.
Parallel.
These ones, they're perpendicular. You see how the sign changes? The sign changes and it's flipped. Okay, so A is perpendicular. I'm just going to use the perpendicular sign. B, let's look at B. B is -3 and positive 3. Is that perpendicular? It almost is perpendicular. The sign changed, but did it flip? No, it did not flip, so this is neither. Okay, looking at C. C is 10 over 12 and -1 and 1/5. They're trying to be all tricky right here. If you said neither, unfortunately, you're not correct. What you have to do is you have to simplify this, and so I get 5 over 6. I divide the top by 2 and the bottom one by 2. So a fraction simplified, it's 5 over 6. And this one right here, in order to see if it's that flipped, I have to change that into an improper fraction. To do that, I have to go 5 times 1, and I have to add 1. What's 5 times 1 plus 1?
6.
So this is actually 6 over 5. And is it positive or negative? It's negative, because there's a negative right there. So are these perpendicular? Are they flipped and opposites? Yes, they are flipped and opposites. Now I'm saying flipped, but the academic word is reciprocal. Okay, so these are perpendicular also. Check this out. 1/2 and 1/2. That's a great question. If they have the same slope, they are parallel. Ooh, that's a great question too. Are they like on top of each other? Not really. But let me do the next questions, and then you'll start seeing like the differences between parallel and perpendicular. Okay, this one says write an equation. Okay, the equation of a line is this, and it says write a parallel equation. So we got to write a parallel one. That means it has to have the same slope. So let's take a look over here at my friend Desmos, and let's put in what was that first equation? Y equals what?
Y, we can write them down.
Yeah.
No, it's 1/3. So 1 divided by 3, and then we have x. And then it was -2, right? Okay, so here's here's this line. Okay, if I want a parallel line, I just have to have that same slope. So if I put in y equals 1 over 3 x, I get a line that is parallel to it. You guys see that line? Okay, notice that it doesn't say +0 because you don't need +0. I mean, that's the y-intercept here, but can it be something different?
Yeah, it could be like plus x.
No, give me a number.
2.
6. Okay, so I just threw in 6 plus 6.
21.
Okay, are they still parallel?
No.
Yeah. What about if you put 21?
If I pick 21, it will also be parallel, but 21 is too far up, so I have to zoom out a little bit. So I zoom out. I still have parallel lines. Okay, you want to plug in -2? You want to see what happens? Isn't that the same equation? Okay, these are the same equations, so you get the same line. They have the same slope, but you can't really say that they're parallel because they're the same line.
Yeah.
So yeah, they're the same line. It's not like they're different lines. But if I put 2.1, are those lines identical? No. They're right on top of each other. It looks like, huh? But if so when you write this, you just have to make sure that you have the same slope. 1 over 3x. and you can put whatever you want right here, but you can't have the same y-intercept. Looking at the next one, it says perpendicular. Same idea, you just have to change the slope. So I have plus 5. If I change the slope to perpendicular, you flip it. 3 over 1 is the same as 3 over 1 is the same as 3. Okay, so I can put 3x right here, but I can't just leave it like that. These are not perpendicular yet. What do I have to also change? The sign. Yeah, change it to a negative. So here we have a perpendicular line and a parallel line. It doesn't matter what y-intercept you put there. Only thing that matters is the slope. Let's take a look at that on Desmos. So here's my line again. Let's zoom out a little bit more. Here's my line again. If I put negative 3x, you can see that they form right angles. If they form right angles, then you know that they're perpendicular. It doesn't matter what the y-intercept is. You could change the y-intercept, it moves, but it's still perpendicular. Alright, going to number 16. Let's see, 16, so it gives us this equation. We're supposed to write a line that's parallel to it, and it's supposed to contain 8, 1. How am I going to do that? What's the slope of this equation?
This slope is 3.
Now this is standard form.
Oh.
If I have standard form ax plus by equals c, do we know, is that a supposed to be the slope? Because it's right next to the x? No, that's kind of tricky though. Because if you look at slope-intercept form, y equals mx plus b, the slope is right next to the x, right? But here it's represented with an m. Thank you. So in order to find the slope of this standard form equation, we have to write it in slope-intercept form equation. So we're going to change this by solving for y. So we're going to write down, let's see, 3x plus 4y equals 4. So we got to get the y alone. So I'm going to subtract 3x first. We have 4y equals 4 minus 3x. Now how am I going to get rid of that 4? Divide by 4, so I get y equals, what's 4 divided by 4?
1.
And what's negative 3 divided by 4? Negative 3 over 4x. So what's my slope? Alright, the slope is negative 3 over 4. So now I know my slope is negative 3 over 4. And the parallel slope is the same thing, isn't it?
Yeah.
Yeah. Parallel stays the same. We gotta have the same slope. Okay. Now, how am I gonna write my equation? Do we have a point and a slope? Because that's what we need. If we want to write equations, we have to have a point and a slope. Do we have a point and a slope for this?
Yes.
Yeah, what's my... Well, we know the slope. Slope's right here. Right here. Because it has to be parallel, right? Okay, what's the point they give us? 8, 1. So, 8, 1's right there. So, we're going to use point slope form. We have y minus... What's the y?
Y is 1.
Okay, somebody else now. What's my slope? Nope, negative 3 over 4. Good job paying attention, guys. And then we have x minus...
8.
8. All right. That's it. That's all you have to do. There's an equation that has that point and is parallel. Now this problem right here is almost the same thing, except now it's asking for perpendicular. This actually, I think, is easier. Because look, what form do they give it to us?
They give us like the...
Yeah, it gives us in slope-intercept form, so we know what the slope is. So if my slope is, what's the slope for that? 5.
And y is
Slope.
perpendicular would be...
Perpendicular, we got to flip it and change the sign. So to flip 5, we got to put a 1 underneath it, and we can flip it. So 1 over 5, and then we have to change it to negative. So there's my perpendicular slope. Are we given a point? Yes, our point is right here. So we go y minus 2. That's my y. And then my m is negative 1 over 5. X minus, and then what's my x? Oh, it's negative 10. So that means we just go plus 10. So there's your perpendicular equation.